All right, let's continue our Exam 2 study guide problems for chapters 6 and 7. First, we're going to cover the normal distribution in Excel. So in this problem here, we have money spent on food per visitor at Legoland is normally distributed with a mean of $32.50 and a standard deviation of $10. So here's our function norm.dist, and the inputs are going to be our x, the mean, the standard deviation, and cumulative. So what's nice about the continuous probability distributions is you really don't need to worry too much about what x to use. So let's work through the first problem. What is the probability that a randomly selected park visitor will spend less than $20? So we're going to enter norm.dist. We're going to enter 20 that's given in the problem, the mean of 3250, the standard deviation of 10, and true for cumulative since we're counting up to $20, so less than $20. And we get 0.1057. Now in problem B, what is the probability that a randomly selected park visitor will spend more than $40? So we're going to use the complement rule here since we're interested in more than 40. So we're going to equals 1 minus norm.dist, then 40 given in the problem, and then the mean of 3250 and a standard deviation of 10, and true for cumulative. So that's going to give us 0.7734. and do 1 minus that number equals 0.2266. All right, let's work through an exponential distribution problem. So we're given that failures for an electronic component are exponentially distributed with a mean of 50 hours between consecutive failures. So we talked about in the last video that for the exponential distribution, we're looking for probabilities between events. So we wanted, what is the probability that a randomly selected part will fail in less than 10 hours? So here's our Excel function, expon.dist, then we're going to enter x, and then lambda, and then cumulative. So for the exponential distribution, our lambda is going to be 1 divided by the mean. So the mean in this problem was 50 hours, so we're going to have 1 divided by 50 equals 0.02. The value of interest, or A, also the x in Excel, is going to be 10. So we're given that we're looking for the probability of failure in less than 10 hours. So then we just need to find the probability that a part will fail in less than 10 hours. So we're going to enter expon.dist, then we're going to enter t for a or x, and then 0.02 for our lambda, and then true for cumulative, and we get 0.1813. All right, let's work through a sampling distribution of the mean problem next. So we have that the speed commuters typically drive on the 5 freeway is normally distributed with a mean of 75 miles per hour and a standard deviation of 10 miles per hour. If 16 commuters are randomly sampled from the population, we want to solve for the following. So the first part here is we want to identify what are the z values for 70 miles per hour and 80 miles per hour. So here's our formula for z, and so we're going to go ahead and plug in the values from the problem. So in the numerator, we're calculating our sampling error. So we're going to take 70 miles and then subtract the mean of 75 miles per hour. And then the denominator, this is our standard error. So we're going to take the population standard deviation of 10 hours, and then we're going to take the square root of our sample size. So in the numerator, we have -5 for the sampling error, and then 2.5 for the standard error of the mean. And that gives us -2 for 70 miles per hour. Next, we're going to calculate the z for the 80 miles per hour. So we're going to do the same thing now, and we're going to take 80 minus 75. The denominator is going to remain the same. So in the numerator, our sampling error is now 5. Our denominator is 2.5, and we get a z value of 2 for 80 miles per hour. Now that we have our z values, we're going to work on the next part. So what is the probability that the sample mean miles per hour will be between 70 and 80 miles per hour? So we're going to be using in Excel the norm.s.dist function, and z will be the input in cumulative. So this problem is a little tricky because we're interested in between two numbers, between 70 and 80. But we know in Excel, they calculate the cumulative distribution from left to right. So what we're going to do is we're going to calculate the cumulative distribution for both of these numbers. So first, let's go ahead and do 80 miles per hour. So we're going to input equals norm.s.dist to the z value for 80 miles per hour and true for cumulative, and we get 0.97725. So let's go ahead and do the same thing for 70 miles per hour. So the z was -2, so norm.s.dist, -2, and true for cumulative, and then that gives us 0.02275. So in order to calculate the probability between 70 and 80, we'll simply just take the probability of less than or equal to 80, or 0.97725, and we'll subtract the probability of less than or equal to 70 of 0.02275, and then that will give us what's left in the middle, and that will be 0.9545. All right, let's wrap this up with a sampling distribution of a sampler proportion. So we're given that the proportion of Georgia peaches that get damaged during shipping is thought to be 10%, or 0.10. To validate this, we're going to take a random sample of 100 peaches, and we found that 16 peaches are found to be damaged. What is the probability of having 16 or more damaged peaches in the sample? So the first part is you just want to identify what the population proportion is, or P. So this is actually given to us in the problem as 0.10. So next we want to calculate the sample proportion, or P bar. So that's going to be the number of peaches in the sample that would be damaged, or 16, divided by the sample size of 100 peaches equals 0.16. So the first step here is now we want to calculate the z value of the sample proportion that we found in part B. So here is our formula for z. It's going to be P bar minus P, or the sampling error, and then our standard error of the proportion is P times the complement of 1 minus P divided by the sample size. So we're simply just going to plug in our numbers and solve. Now this formula is how you would do it in Excel. So in the numerator, we're going to do 0.16 for P bar, or the sample proportion, minus the population proportion of 0.10, and then divided by the square root of P, the population proportion, 0.10, times 1 minus 0.10, and then divided by the 100 sample size, and we get 0.06 in the numerator, 0.03 in the denominator, and then that's going to equal to 2. So we have a z value of 2. So now all we need to do is we need to plug in into the norm.s.dist function. So what is the probability of having 16 or more damaged peaches in the sample? So we are looking for 16 or more, so we know we need to use the complement rule. So it's going to be 1 minus norm.s.dist, the z value of 2, and true for cumulative. And so that's going to be 1 minus 0.97725, and that gives us 0.0228.